Hello everyone, and welcome to the MLOps workshop. In this video, we're going to be walking through Dockerizing our model, which is being served behind a Flask API. So if you haven't already, you should watch the video where we walk through serving our packaged model via Flask API. And if you have seen that, you should notice that the contents of this API directory should look familiar. We have our requirements. We have our app.py. This is where all of our API-specific logic will live, where we're loading in our model. So from that previous video, basically what I've done is I've taken all of its contents and I've put it inside of this /API directory. So now we have a few new files here. Let's take a look. The first one that we're going to walk through is a Dockerfile. So you should have also all watched the Docker intro videos. Docker is an extensive tool. It could, discussing it could span multiple workshops. So the idea of this workshop is not to become an expert on Docker, but to mainly see how you can use it to containerize our model serving layer. So this is just a quick standard Docker file. Here we can see we're going from Ubuntu, so this is going to be the base image in which our container is built from. Setting some environment-specific parameters. We have our this line right here, env Debian frontend equals non-interactive. This isn't always necessary, but I've found in a few situations where when you try and install a package, sometimes, in the CLI, it'll prompt you to continue. This just prevents that from ever occurring. Here we're setting our working directory. So what is a working directory? If we go and take a look at the documentation here. So this page that I'm on right now, docs.docker.com, this reference page. It's a great resource to utilize when you're first learning Docker. So let's take a look at what Workdir does. So we can see the Workdir instruction sets the working directory for any run, command, entry point, copy, or add instructions to follow. So this just essentially sets the context from which all of our commands below are going to be run. So here we're doing some standard system updates and configuration. We're just running an app.getUpdate. Here we're installing mini conda. So we don't need a full-blown conda environment. Most of the time Docker containers are kept relatively lightweight. So here we're just using wget to install mini conda. We're setting this onto this sets environment variables. So we're just adding this onto our path environment variable. And now down here is where it gets interesting. So we can see we have copy /API to /root. So what this is doing is we can see that everything inside of the directory that's alongside the Docker file is known as the build context. So we have access to everything inside of this directory. So what we're doing here is we're copying our API directory and we're placing it into the root of the container. So this is all of our Flask serving logic, as well as all of our model and the artifacts. Next, we're copying over our start.sh into root. We'll take a look at that in a minute. Here we can see we're calling run conda env create, and we're passing in the file root model conda.yaml. So this should look familiar to you. This is the file that was packaged along with our model. This was the environment that we specified we should use at inference time because it matches our training environment. So if we go and take a look, you can see this is just installing PyTorch, sklearn, CloudPickle, MLflow. All of this should look familiar to you. So since that environment file was packaged with the model, we have access to it in our Docker container. So we're creating that conda environment. Here I'm just adding source activate MLflow env. So this is the name of the conda environment. Again, we can find that down here. And I'm just adding this to the bash RC. basically what this means is every time we open up a new session of a terminal, it will activate our Conda environment. So down here, we want to activate this Conda environment, and we also want to pip install our Flask level requirements. So this only specifies the requirements that we stated at model building and training time, whereas we also have requirements over here for Flask specific, like the Flask library and pandas. So what we're doing is we're starting our Conda environment here, and we're pip installing the root requirements.txt. So this is the API level requirements, and we're installing that into this Conda environment. So we'll have everything that we need for serving this model in one environment. Okay, so now we have a couple other commands down here. This is making our start.sh just executable, and all Docker files should really have an entry point. This means that when containers, in general, they're meant to be single purpose. So, when I start, I'm supposed to do one thing well, and then when that process stops, the container will stop. It's essentially just a single purpose, self-contained environment. So that's what this entry point means. This means when the container starts up, I want to run root.start.sh. So what's in start.sh? There are a few ways that I could have structured this, but I wanted to show you this process in particular because it's not an uncommon use case to want to run multiple commands when you're starting up a container. So one of the suggested ways is to create a shell script. Here we have our bash script, and then you can have this whole series of commands to run on startup. So here we can see source, activate, we're starting our MLflow env conda environment, and then we're calling Python root app.py, which is our Flask logic. So this is going to say, the entry point is at this script, which we've now made executable. And when that runs, it's going to start our Flask API. Okay, so now that we know what this Dockerfile is actually doing, let's go ahead and see how we can use this. So I'm sure you know already from watching the previous Docker-related videos, but there's two main concepts with Docker. We have images and containers. A container is essentially a running version of an image. You can think of an image as just being a blueprint of what a container should do. So we use a Docker file to to build an image that we will later run. So let's go ahead and see how we do that. Okay, so we can see I'm in my Docker Flask _API directory. Here's our contents. So the Docker build command takes I'd say one of the more complicated things when first learning Docker is the sheer number of flags that you can pass into the command line interface. So when I say flag, I mean stuff like -t. -t stands for tagging. So I want to tag this image, which essentially names it. I want to name my image Flask _API. And we can see we have a space and then a period here. This last part represents the build context. So where am I running this Docker build from? So we can see that this means Docker build an image, name it Flask _API, and use our current directory as the build context. So let's go ahead and run this. So I've already ran this before the video, which is why that went through really quickly. If you were running this for the first time, it would probably take 5 minutes or so to walk through running everything because it has to pull in this Ubuntu base image, apt-get update, install requirements, create the conda environment. But one of the nice things about Docker is it basically, each level in this Docker file represents what's called a layer. and it will cache all of these layers so that it can reuse them when we're running Docker build multiple times in a row, and it makes for a much faster process. So now that we've built our image, let's go ahead and run a Docker images. And here we can see we should have two images. Ubuntu 18.04, which is the base image that we built our image off of, and we should see our Flask _ API. So this is the one that we built, and we tagged it Flask API. Great. So now let's run our Docker image. So again, like I mentioned, one of the most intimidating parts of learning Docker is all of the flags. So we have, but the documentation is great. So if you're ever confused about anything you see Docker related, just head to docs.docker.com and you'll find what you're looking for. So here we're calling Docker run. We're passing the -it. This just means the -interactive mode that we're going to be running this container in. --rm just means when our container stops or when we kill it, automatically remove the dangling container. So this is just kind of best practices for cleaning up, keeping your Docker environment clean. When the container's not running, just make sure you go ahead and remove it. Here we're passing in a --name / container. So this is similar to how we tagged an image before, and we're passing in -p 5000. So what's this doing? This is mapping the port 5000 on our local machine to the port 5000 on the Docker machine. So if you remember, we are running our Flask API at host port 5000. So basically when the container starts up, it's going to start this Flask API. This Flask API is going to be running on port 5000 on the container. So not our host machine, on the container itself. And this just means that when I go to /localhost in my browser at port 5000, bind that to the container port 5000. And we also have to pass in the name of the Docker image that we want to run. So let's go ahead and run this. And there we have it. This should look familiar to you. This is the Flask server starting up messages. So now we should be able to go to our localhost 5000. And here we go. We can see our metadata that we packaged alongside our model. And we should also be able to send post requests to the /predict method. So this is the same. This is Postman. If you aren't familiar with this, I highly recommend you download it. It's a great tool for testing APIs and endpoints. So here we're passing in our data key with, we're going to pass in two feature vectors here. These are two samples from the iris dataset. And here we can see we get our predictions back. So yeah, it was, again, something I want to continuously stress over and over again is the main point of this MLOps workshop is to show you how structuring things in the proper format allows us to easily and rapidly spin up environments, right? So we packaged our model using MLflow, so it's in a consistent format. We can just throw it alongside an API and call python.loadModel and .predict. And now that we have our Flask API Dockerized, or containerized, if you will, it's literally as simple as running one command. And, our API is up and running, and it's serving our model. And by doing it this way, by containerizing the application, there's just almost too many benefits to name that we get by structuring our applications this way. We get resiliency, we get very easy horizontal scalability, and it's super versatile in that you can basically run it. Now that we have a Docker container or a Docker image that we can create a container from, we can basically run that on any environment. As long as it has Docker, it will run on any of those environments, and it will run the exact same way every single time. So I could push this Docker image up to Docker Hub or up to ECR in AWS or any of the Azure or Google Cloud related repositories, and then I could pull that into a cloud instance, and all we would have to do is Docker run, and it's up and running. Tools like AWS Fargate or ECS, they use containers as well. So all we would do is point a service at a container, and it runs the exact same way. Kubernetes, same thing. It uses containers. It's a container orchestrator. Now that we have a container, it will just run on so many different environments, and it's such a great way to package up applications.